Have you ever wondered how it all began? The universe, that is. It's a question that has echoed through the ages, a mystery that has enticed philosophers, scientists, and thinkers alike. The origin of the universe is not merely a topic of idle curiosity. It's a riddle that, once solved, promises to unlock the secrets of existence itself. We humans have always been fascinated by the unknown, the unexplored, and the unexplained. We have gazed upon the night sky, awed by the vast expanse of twinkling stars and galaxies, and pondered about our place in this grand cosmic tapestry. From the ancient civilizations who crafted elaborate myths and stories to explain the cosmos, to the modern scientists who strive to unravel the mysteries of the universe through rigorous observation and analysis, we have always been driven by an insatiable thirst to understand our origins. And perhaps the most compelling answer we have come up with so far is the Big Bang theory. This theory suggests that the universe as we know it started with a small singularity, then expanded over the next 13.8 billion years to the cosmos that we know today. But what is the Big Bang theory really? Is it merely a fanciful idea, or does it have solid scientific backing? The Big Bang theory is not just a theory in the everyday sense of the word, it's a scientific theory, which means it's based on a vast body of evidence and is widely accepted by the scientific community. It's a comprehensive explanation of the observable universe, from the smallest particles to the largest galaxies. But don't let the name mislead you. The Big Bang wasn't an explosion in the traditional sense, it was a rapid expansion of space itself, a concept that can be a bit hard to wrap our heads around. So, how did it all begin? Let's journey back to the very beginning of time. Imagine, if you will, a time before time, a moment when there was nothing, and then, suddenly, everything. Before the Big Bang, our universe was in a state that is almost inconceivable. Scientists suggest it was an entity of infinite density and temperature with no dimensions, no space, no time, a concept we refer to as singularity. Imagine, if you can, a dot, infinitely small, yet containing all the energy that will ever exist. A dot that is everything and nothing, all at once. This singularity didn't exist in space because there was no space. It didn't exist in time because there was no time. These are concepts that we, as humans, understand and experience, but they are also constructs of the universe. And this universe, as we know it, did not exist yet. What we understand as space and time began their existence at the moment of the Big Bang. They are the fabric of our universe, woven together into a four-dimensional tapestry that we call space-time. It's hard to imagine, isn't it? A world without space, without time, without matter, but that's what scientists believe existed before the Big Bang. Now, you may ask, what was there before the singularity? The answer, quite simply, is that we don't know. We can theorize and speculate, but the truth is, our understanding of physics, our grasp of the laws of nature, breaks down when we attempt to peer that far back. It's like trying to see beyond the horizon, beyond what our eyes, our tools, and our knowledge can reach. The singularity was a point of infinite potential. It contained all the energy, all the mass, all the complexity that would become our universe. It was the seed from which everything we know sprang forth. And then, in less than a second, everything changed. In an instant, the universe expanded out from a single point in a violent burst of energy and matter. This was the Big Bang, an event so colossal that it's challenging to comprehend. In a flash, everything that would ever exist sprang into being. But it wasn't a simple explosion. Rather, it was an intense, rapid expansion of space itself. We can think of the Big Bang as the start of time and space, but that's not the end of this explosive tale. As the universe began to cool down, it entered a phase known as inflation. During this period, the universe ballooned in size at an astonishing rate. In less than a blink of an eye, it expanded from a point smaller than an atom to about the size of a grapefruit. It's as if you took a tiny speck of dust and expanded it to fill the entire observable universe, all within a fraction of a second. But the universe didn't just get bigger, it also became filled with elementary particles. Quarks, the smallest known particles, began to combine and form protons and neutrons. These protons and neutrons eventually came together to create the first atoms, primarily hydrogen and helium. This process, known as nucleosynthesis, was the first step in the creation of all the matter we see around us today. And then, there was light. As the universe continued to cool and expand, photons or particles of light were finally able to travel freely. This decoupling of light and matter resulted in the cosmic microwave background, a faint glow that fills the universe and serves as a snapshot of the universe's infancy. So, What started as a singularity, a point of infinite density and heat, rapidly inflated into a vast cooling universe filled with elementary particles and light. It was a period of extreme change, expansion, and creation. From this fiery, chaotic beginning, the universe as we know it began to take shape. As the universe cooled and expanded, the first stars and galaxies began to form. This was a pivotal moment in the history of our universe, a transition from an expanse of heat and energy into an environment where matter could exist and evolve. So how did this happen? The answer lies in the primordial elements created in the Big Bang. As the universe cooled, protons and neutrons began to fuse, forming the nuclei of the lightest elements, hydrogen and helium, with trace amounts of lithium and beryllium. These elements, scattered throughout the universe, would provide the raw materials for the first stars. Now imagine these elements floating in the vast cosmic soup. They aren't evenly distributed but clumped together because of minute differences in density. These clumps, under the relentless pull of gravity, began to collapse in on themselves. As they did, they heated up and started to glow, marking the birth of the first stars. These stars, burning bright and hot, started to form clusters which eventually coalesced into the first galaxies. But what's fascinating is that we have a way to witness this era of star and galaxy formation. We call it the cosmic microwave background radiation, or CMB for short. The CMB is the afterglow of the Big Bang, the oldest light we can see, which has been traveling through the universe for nearly 14 billion years. It provides us with a snapshot of the universe as it was about 380,000 years after the Big Bang, when the first atoms were forming and the universe was becoming transparent to light. The CMB is not just a relic of the past, but a tool for understanding how the universe evolved. By studying it, we can learn about the early universe and the birth of the first stars and galaxies. These first stars and galaxies were the seeds for the cosmic structures we see today. They set the stage for the formation of larger structures and ultimately, for the creation of everything we know and see in our universe today. So in a way, we owe our existence to these primordial stars and galaxies. Fascinating, isn't it? From that violent beginning, the universe has evolved into a vast, complex system of galaxies, stars, and planets. This is where we find ourselves today, suspended in an ever-expanding cosmic tapestry that's over 13 billion years old. The universe as we know it is a beautiful blend of order and chaos, filled with an almost unimaginable number of galaxies, each one teeming with billions upon billions of stars. These celestial bodies follow the laws of physics, the same laws that govern our own planet, creating a cosmic ballet of gravity and motion. What's even more fascinating is how the universe continues to evolve. The galaxies are moving away from each other at an accelerating pace, a finding that led to the current theory of dark energy. This mysterious force, while still not fully understood, appears to be causing the universe's expansion to speed up, rather than slow down as initially expected. And what of the future? Scientists predict that in billions of years, the universe will continue to expand, possibly at an ever-increasing rate. Eventually, the galaxies will move so far apart that they'll no longer be visible to each other. The universe will become a much darker and lonelier place. But don't worry. This is not expected to happen for another 100 billion years or so. In the grand scheme of things, our existence is but a blink in the cosmic timeline. Yet it's during this blink that we've managed to understand much about the universe's beginnings and its possible future. We've learned that it all started with a Big Bang, a singular event that birthed all matter, energy, space, and time. And so, from a single point the universe was born, and it continues to expand and evolve just as our understanding of it does. The story of the universe is the story of us. It's a story of constant discovery, of reaching for the stars and beyond, and of trying to make sense of our place in the cosmos. It's a story that is far from over,